Hey everyone, welcome to this explainer. Look, if you're an indie mobile game dev, you already know the drill. You started this whole journey because, well, you just love building games. But somehow, you've ended up wearing literally 100 different hats. You're the lead programmer, the QA tester, the marketing team, the monetization manager, and the customer support desk. It's exhausting, and quite frankly, it takes you away from the code. But today, we're going to look at a state-of-the-art solution that's basically going to give you your life back.
Seriously, just think about it for a second. How much time did you waste this past week on non-coding tasks? Tweaking App Store metadata, analyzing ad revenue spreadsheets. We're trying to figure out A/B testing copy. It's that daily grind that just absolutely kills your momentum. If you're tired of being bogged down by the administrative side of indie development, you are in the exact right place. Because today, we're going to build you an automated co-founder.
Okay, let's dive right into this. We're moving way beyond the basic chatbots you might be used to. A standard AI model is, frankly, stateless. You give it a prompt, it gives you a response, and then poof, it instantly forgets you even exist. What we're talking about today is Agentic AI. We're looking at the evolution from simple prompt response systems to actual goal-directed systems. These agents have autonomous perception, planning, and action capabilities. They operate through continuous control loops to solve really complex problems over time. So here's our roadmap for this explainer. 1. Automating the grind. 2. Agentic reasoning. 3. Memory and making agents stateful. 4. Multi-step prompting patterns. And 5. Building your first agent. Let's get to it.
All right, part 1. Automating the grind and reclaiming your time.
So the fundamental problem for indie devs is bandwidth, right? You need a system that can take a high-level goal, something like optimize my App Store keywords, and just run with it without you having to hold its hand. Listen, a single LLM call is not agentic. If you take away just one thing from this section, let it be that. True autonomy comes from this recurring execution loop. The agent has to perceive its environment or the data you give it, then it plans a sequence of steps, it acts by using tools like calling an external API or running a script, it observes the result of that action, and then it just repeats the process until the goal is achieved. This loop, interacting with tools and memory, is literally the engine of your new digital co-founder. Moving on to part 2, agentic reasoning. Think, act, reflect. Okay, so how do we actually program this brain to process information during that loop? Well, we use specific agentic reasoning patterns, and this brilliantly illustrates our first major pattern, react. React stands for reason plus act. Instead of just thinking in a hidden black box, the agent is prompted to alternate between explicit chain-of-thought reasoning, literally spelling out its logic in a thought block, and taking concrete actions from a predefined toolkit. This continuous thought-action loop is perfect for dynamic, real-time tasks. Imagine you want an agent to pull live data from the Google Play Console API. It thinks about what metrics it needs, executes the API call, observes the JSON response, and then reasons about what to do next. It's like a live debugging partner. But, React isn't the only way. Let's compare React with another pattern called Reflexion. While React is super fast and great for live API loops, Reflexion is really built for iterative self-improvement. It adds a self-critique step after an attempt, storing those insights in memory to try again with a much better approach. So if you're letting an agent figure out why your Unity game logic just crashed, you absolutely want Reflexion. The agent tries a fix, runs the test, observes the crash, reflects on why its previous fix failed, and iterates. It learns from its mistakes. Which brings us to part 3, memory. Making agents stateful. Look, without memory, even the best reasoning loops are kind of useless. Your agent suffers from context rot, basically starting from a complete blank slate every single time you boot it up. To prevent that, we categorize memory into distinct tiers. Working memory is like a temporary scratchpad for the agent's intermediate C# logic while it's actively solving a problem. Episodic memory logs recent actions, like the exact debugging steps it just took. Semantic memory, that's your long-term storage. Think of this as a vector database holding your historical AdMob revenue trends over the last 6 months, allowing the agent to spot long-term patterns. And procedural memory holds your specific coding style guide and rules, so you never, ever have to re-explain your variable naming conventions again. But here's a little secret that production engineering teams know. The biggest challenge in agent memory isn't actually storage, it's extraction. AI agents are incredibly prolific thinkers, but they are terrible self-editors. If you just log everything, they'll generate pages and pages of useless journal text. The solution highlighted in the source material is a structured extraction process, specifically a 7-category self-check gate.
This categorizes things into task, goal, pattern, improvement, knowledge, decision, and question. If the agent extracts nothing useful from a session, this gate essentially forces it to rescan and try again. It's a quality control filter for its own brain.
Now, what's really interesting about this is you don't even need massive, expensive database infrastructure to pull this off. You can use a 5-layer, file-based architecture right inside your local workspace using simple Markdown and JSON files. Raw journals act as the scratchpad, a background extraction process routes the knowledge, trackers preserve the state, knowledge files hold indexed facts, and a shared library holds your global rules. It keeps your agent's memory incredibly clean and, best of all, easily auditable by you.
All right, part 4, multi-step prompting patterns.
So, how do we orchestrate these agents to handle complex multi-stage workflows without them just going totally off the rails? The sources make this incredibly clear. We have to stop writing massive all-in-one prompts. Instead, use the single responsibility principle. A highly reliable agentic system isolates tasks across dedicated roles. You have one agent entirely focused on drafting code or marketing copy, and a completely separate validator agent designed to ruthlessly test and critique that output, divide and conquer. This creates a highly disciplined, declarative workflow sequence: planning, drafting, critique, and revision. Let's ground this in reality for a second. Say you want to independently generate and run Android A/B testing metadata. First, the planning agent looks at your current App Store metrics and formulates a keyword strategy. Second, a drafting agent generates 3 new variations of your app description. Third, a critique agent evaluates those drafts against Google Play's strict policy guidelines. And finally, a revision agent refactors the copy to fix any flagged issues. It's a whole pipeline.
So the crucial point is that you absolutely must enforce strict validation checklists at that critique stage before the agent is allowed to publish anything. You need fact verification to ensure complete alignment with App Store rules, logic verification to make sure the marketing claims actually make sense, style verification to enforce hard character limits and brand tone, and completeness to guarantee every single required keyword is actually present in the text. Doing this is how you build genuine trust in autonomous systems.
And finally, part 5, building your first agent.
So how do you actually start building your first high-quality agent today? Well, it starts with how you write the instructions. You got to stop treating prompts like casual text messages to a buddy and start treating them as formal engineering requirements. You need to define the exact functionality and quality targets. What must this agent achieve? You need to specify the architectural strategy, like what APIs or libraries is it allowed to use. And you must enforce specific lower-level constraints like file paths and coding standards. Listen, spending just 2 hours writing a highly structured, multi-step prompt with a solid memory architecture today will easily save you 200 hours of manual grunt work this year. It's a massive ROI.
So, I want to leave you with this challenge. Look at your backlog. What is the single most tedious, non-coding indie task you are just dreading this week? Is it updating localization files, analyzing player retention data? Pick that one task, open up your code editor, and start building your ultimate agentic co-founder to handle it for you. Thanks for joining me on this explainer. Now go reclaim your time.